kids, I'm Aditi and today we are going to talk about electricity. I'm sure you must have noticed that presently we are living in a wonderful world of electricity and electronics with modern instruments doing miracles. Modern instruments are little miracle these days.
Whenever we need light, we switch on light bulbs. If we feel hot, we switch on the fan or an air conditioner. We can even preserve the foods in a refrigerator with the help of electricity for longer periods of time. In fact, modern ways of communication such as cell phones, laptops and telephones are also dependent on electricity. Thus, all these modern technologies have developed due to electricity. Without electricity, we would have to live in the dark, without electric fans, without water supply, without electric trains, without communication, and many more problems in our day-to-day life.
In this chapter, we will learn about the concept of electricity and its numerous applications.
In 600 BC, Thales rubbed amber and fur cloth and found that both amber and fur cloth acquired the power of attracting small things like paper pieces, threads and cork pieces and etc.
The word for amber in Greek is electron. It acquires the electrical property on rubbing with fur and this process is called as electrification.
Later on, an English physician, Gilbert, in the beginning of the 16th century, showed that if a glass rod is rubbed with silk, it also acquires attractive property. The electricity thus produced by friction is called frictional electricity. We can also produce electricity by combing our dry hair with a plastic comb or by rubbing glass with a dry cloth.
From experiments, it was found that all matter consists of only two types of electric charges, positive charge and negative charge. Ordinary bodies contain both positive and negative charges in equal quantities, and these are called neutral bodies. Like charges repel each other and unlike charges attract each other, just like two magnets.
When bodies are rubbed against each other, they acquire opposite charges by friction and thereby acquire electric property. The electricity produced in this way is called static electricity, as the charge on these bodies is at rest.
Another scientist, Benjamin Franklin, also an American ex-president, proved that clouds contain electric charges by sending kites into the clouds.
Do you know lightning or thunder may occur on rainy days? This is due to the transfer of charge from the top of a cloud to the bottom of a cloud between positive and negative charges, giving lightning.
If the charged particles move from one place to another, it constitutes an electric current. Current flows from a higher energy level to a lower energy level, just like water flows from a higher level to a lower level. Higher energy level is called higher potential and lower energy level is called lower potential. The materials through which current can flow are called conductors and the substances which do not allow the current to flow through them are called insulators. In 17th century, a scientist named Volta invented a cell called the VOLTAIC cell. VOLTAIC cell is also called a primary cell. A primary cell converts chemical energy into electrical energy. The electrode which acquires positive charge becomes the positive electrode, and that which acquires a negative charge becomes the negative electrode. Now, let us see how to construct a VOLTAIC cell.
For this, you will need a jar or a beaker containing dilute sulfuric acid. Insert two rods, one made up of copper and the other made up of zinc in the sulfuric acid. Connect the two rods to a small electric bulb by a copper wire. Then the zinc slowly begins to dissolve in the sulfuric acid and bubbles of hydrogen are formed at the copper rod. At the same time, a current of electrons drifts through the wire from zinc to copper. As a result, this bulb glows and the copper rod acquires positive charge and becomes the positive electrode. Zinc rod acquires negative charge and becomes the negative electrode. Thus, chemical energy is converted into electrical energy.
It is easy to construct a voltaic cell, but it has some drawbacks, also such as local action and polarization. You have already learnt about these in your previous class.
This cell was invented by George LECLANCHE in the year 1865, eliminating the defects of the voltaic cell. The cell consists of a carbon rod C placed in a porous pot P containing a mixture of powdered carbon and manganese dioxide as shown. This porous pot P is placed in ammonium chloride solution in a glass jar. The carbon rod acquires positive charge and becomes the positive electrode. Zinc rod acquires a negative charge and hence becomes the negative electrode. This is also a primary cell because it converts chemical energy to electrical energy.
The LECLANCHE cell is unsuitable for maintaining a steady current over a long period.
It consists of a glass vessel containing a mixture of solutions of potassium dichromate and sulfuric acid. A screw cap S is fitted to the vessel. This screw cap, a zinc plate, is fitted at the middle of the carbon plates. Zinc rod reacts with the acid to get negative charge and becomes the negative electrode, getting negative potential. The difference in potential between these two is called EMF or electromotive force. EMF is defined as the work done in driving current in the circuit and is measured in volts. So, the zinc plate acts as the negative electrode and the two carbon plates together act as positive electrodes. The solution potassium dichromate and sulfuric acid act as electrolytes. Dry cell is modified form of LECLANCHE cell in which liquid electrolytes are replaced by thick pastes. Now, let us give a look at the constituents of dry cell. A dry cell consists of cylindrical zinc vessel covered by a cardboard casing and is sealed with pitch. This zinc vessel acts as a negative electrode. The carbon rod at the center acts as a positive electrode and it is surrounded by the paste of carbon and manganese dioxide. The remaining space is filled with a paste of ammonium chloride and zinc chloride as shown in the slide. These two pastes are separated by porous sheet. Dry cells are easy to handle as they do not contain any solutions, so they are widely used in radios, torches, tape recorders and etc.
Now, the most interesting thing is that how do these cells work? How are these cells able to produce electricity? In all these cells, zinc is negative electrode and copper or carbon is positive electrode. The solutions such as sulfuric acid, that is H2SO4, or ammonium chloride, that is NH4Cl, acts as electrolytes. As shown in the cell reactions in the slide, zinc reacts with sulfuric acid or ammonium chloride to produce hydrogen ions which are positively charged hydrogen atoms. Thus, zinc rod becomes negatively charged electrode. These ions travel towards the copper electrode and give up their positive charge to copper electrode, so that it becomes positively charged. Thus, the potential of copper electrode increases. In case of zinc, it gets negatively charged, so the potential of it decreases. The difference in potential between the electrodes is called EMF, that is electromotive force. EMF is defined as the work done in driving current through the wire, and it is measured in volts. Thus, cells are able to convert chemical energy into electrical energy or EMF. We can summarize the characteristics of the different cells as shown in the table. Thus, zinc reacts with acid to get negative charge and becomes the negative electrode. Copper rod acquires positive charge to get positive potential. The difference in potential between the electrodes is called EMF, that is electromotive force. It is measured in volts. If a number of instruments are connected to a cell or group of cells is called an electric circuit.
A cell is represented by the symbol E as shown. The long line with a positive sign indicates positive electrode, and a short line with a negative sign indicates a negative electrode. When these electrodes are connected by metallic wire to a number of instruments like the key K, an electric bulb B, etc. as shown, then it's called an electrical circuit. In an electrical circuit, current flows from the positive electrode, which is at a higher potential, to the negative electrode, which is at a lower potential. The key K helps in either closing or opening the circuit. When the key is closed, the circuit is complete. Current flows through the circuit and the bulb glows in the circuit.